Two turbochargers, two worlds. Under peak loads, a conventional turbocharger becomes so hot that it glows, unlike the innovative exhaust gas turbocharger by Continental.
This is a real breakthrough technology. Continental developed a turbocharger with a water-cooled turbine housing made of aluminium for passenger car applications.
Before such pioneering technology can be used, it has to prove its worth compared to conventional systems.
We are here in Regensburg in our turbocharger test center. Here we are testing turbochargers under realistic conditions, especially very high temperatures and very high shaft speeds.
The test bench and the turbocharger must be carefully prepared for these extreme loads, because the temperature of the exhaust gas at full load increases in the vehicle to 1000 degrees Celsius. For the testing cycle, this means similar hot gas temperatures and turbocharger rotational speeds of 205,000 revolutions per minute. And what about the conventional turbocharger? It starts to glow.
The hot gas test stands are constructed to simulate normal car driving conditions. In this thermoshock cycle, we are alternating the inlet gas temperature between 200 and 1000 degrees continuously.
Due to these high loads, there is no way you can get away from using steel in conventional turbochargers. In contrast, the turbine housing of the new turbocharger by Continental is water-cooled. This prevents any part of the housing from getting hotter than 250 degrees and allows you to use aluminium, which is less expensive.
The surface temperature of the turbine housing is very low. Expensive heat shielding is not required.
In principle, the new turbocharger by Continental works the same way as conventional models. The intake wheel is set in motion by the exhaust flow and transmits the energy to the compressor turbine wheel. The permanent water cooling, which originates directly from the engine cooling circuit, prevents the housing from becoming too hot. Aluminium also brings advantages in terms of weight. Conventional turbine housings made of steel weigh a good 4.4 kilograms. The new housing is around 1.7 kilograms lighter. Even taking into account the weight of the cooling water, the aluminium housing is still 1.2 kilograms lighter than its steel counterpart.
The water-cooled turbine housing, made out of aluminum, is a new development for small gasoline engines. This has been launched for the first time in serial production.
A direct comparison of the test cycles proves that the new turbocharger can even cope with the most demanding requirements. While the conventional model on the left starts glowing after only 55 seconds, the new turbine housing remains unfazed by the high temperatures throughout the test cycle.
This design offers four major advantages. Weight, cost. We use aluminium instead of expensive heat-resistant alloys. Fun to drive and fuel consumption.